Welcome to The Explainer. Think about today's data centers. Applications are constantly talking to each other. But how do you actually control those conversations to keep everything secure? Well, in Cisco's Application-Centric Infrastructure, or ACI, the answer is an amazing little thing called contracts. And in this explainer, we're going to dive deep and figure out exactly how they work.
So let's start with the big question, the one that keeps every network security engineer up at night. In a zero-trust world where we assume nothing is safe by default, how do you let your applications talk to each other without opening up a huge security hole? We need a really smart, really granular way to permit only the conversations we want. And in ACI, well, the answer is the contract.
All right, so here's what we've got on tap. We're going to start with what contracts are, then get our heads around the provider-consumer model. After that, we'll deconstruct a contract, see how subjects direct traffic, how filters define the rules, and we'll wrap it all up with a seriously cool optimization tool called vZeni.
All right, let's jump right in. So, what exactly are ACI contracts? Before you can really do anything meaningful in ACI, you have to understand the policy layer. And let me tell you, contracts are the absolute foundation of that policy.
Okay, the easiest way to think about a contract is like a bouncer at a club. It's a set of rules that you, the administrator, get to define. These rules control who gets in and who doesn't. In ACI, the people are groups of applications called endpoint groups, or EPGs. And the most important thing to get is that it's an allow list model. If your name's not on the list, you ain't getting in. Simple as that.
Now, this is what makes ACI so powerful. Its entire philosophy is deny by default. Imagine you have two different application EPGs. Right out of the box, they can't talk to each other. At all. It's like they're in separate soundproofed rooms. This means if a hacker gets into one app, they're trapped. They can't just wander around your network. To allow any communication, you have to explicitly build a contract. This is that whole zero trust idea in action.
So, to wrap this section up, let's just hit the 4 big principles. First, you build your policies using things called subjects and filters. We'll get to those in a second. Second, you get to control the exact type of traffic you want. Third, and this is the big one, remember, everything is denied by default. And finally, the way traffic moves is all based on who's providing a service and who's consuming it.
So if everything starts out silent, how do we get anyone talking? Well, it all boils down to this really elegant idea called the provider-consumer model.
Take a look at this. It's your classic 3-tiered app. The EPG client needs to talk to the EPG web, right? The web server has a service, HTTP and HTTPS. So the web EPG provides a contract that allows that traffic, and the client EPG consumes it. See the little P and C icons there? That's all they mean. And that same logic just repeats all the way down the stack.
Now this is where it gets really efficient. Check out the bottom of the diagram. We've got a single management EPG that needs to manage all 3 tiers using SSH and ICMP. Instead of making a separate rule for each one, which would be a huge pain, you just create one contract for SSH and ICMP. Then the web, app, and DB EPGs all provide that same contract. Bam! One and done. Super clean and so much easier to manage.
Okay, we get the provider-consumer thing. Now let's really get into the weeds. We're going to pop the hood on a contract and see what makes it tick.
It's actually pretty straightforward when you see it laid out like this. At the very top, you've got the contract itself. Nestled inside that, you have one or more subjects. And then inside each subject, you have one or more filters. The way to remember it is this. Filters define what traffic is allowed, and subjects define the direction of that traffic.
So, let's just quickly break that down. Subjects handle the traffic direction. Filters are the nitty-gritty, the specific protocol and port, like TCP port 80. Actions, yeah, you're almost always just going to say permit. And scope, okay, scope is a big one. This decides if your contract works just in one little area, across a whole tenant, or even globally across the entire fabric. Really important for shared services and stuff like that.
Okay, let's focus on subjects for a minute. This is where people sometimes get tripped up, but it's also where you get a ton of control over your traffic flow.
So check out this example. It's pretty basic. The consumer EPG web is allowed to start talking to the provider EPG app on a certain destination port X. It's a one-way street. That first packet goes through, no problem. Seems simple enough, right?
But hold on a second. What about the response? I mean, for pretty much any real conversation, especially with something like TCP, the server has to talk back to the client. It needs to complete the handshake. A one-way street just isn't going to cut it.
Now, you might see this little checkbox in ACI that says apply in both directions and think, perfect, problem solved. But nope, it's a classic trap. Look at the diagram. When you check just that box, ACI applies the exact same rule to the return traffic. It's still looking for traffic to have a destination port of X, but the return traffic is coming from port X. So the rule doesn't match and the traffic gets dropped. The conversation dies.
So here's the magic trick. There's another checkbox called reverse filter ports. When you enable both of these options together, ACI gets smart. It knows to flip the logic for the return trip. It says, aha, for the traffic coming back from the provider, I should be looking for a source port of X. And just like that, the two-way, stateful conversation works perfectly.
So, what's the bottom line here? For just about any stateful application you can think of, which is most of them, you're going to want to have both apply in both directions and reverse filter ports enabled. Just do it. It'll save you a world of troubleshooting pain later on, trust me.
Okay, we've nailed down subjects. Now let's talk about filters. This is where we define the actual language of the network. What exactly are we allowing to be said?
A filter is basically a collection of rules, and each one of those rules is called a filter entry. Now, if you come from a traditional networking background, this will feel super familiar. A filter entry is just ACI's name for an access control entry, a single line in an ACL.
And here's what that looks like right in the ACI interface. See, we're making a filter called web_filter, and inside it, we've added two little entries, one for TCP port 80, which is HTTP, and another for TCP port 443 for HTTPS. That's it. This one filter now allows all of our standard web traffic.
This table just gives you a taste of how specific you can really get. You can match on layer 2 stuff like ether type, layer 3 like the IP protocol, TCP, UDP, you name it, and of course the layer 4 port numbers. There's even a stateful flag you can set, which basically tells ACI to pay attention to things like the TCP ACK bit, making sure the session is legit.
All right, time for our last section. And we've saved one of the coolest, most powerful features for last. Let's talk about a thing called DCACI and how it can make your life a lot easier.
This picture says it all. It really does. Look at the before scenario on the left. You've got some shared service, and you have to manually apply that contract to every single consumer EPG. Now imagine you have hundreds of them. Ugh, what a nightmare. Now look at the after on the right. You use this one magic object called DCACI. It's basically a wildcard for all EPGs in this VRF. You apply the contract just once to DCACI, and you're done. So much cleaner.
And the benefits here are massive. First, obviously, it's way simpler to configure. But the really big deal is what it does for your hardware. It saves a ton of that precious TCAM space on your switches. Instead of burning a hardware entry for every single EPG to EPG rule, it just creates one. That is huge for performance and scale. And the best part? It's totally automatic. Spin up a new EPG in that VRF tomorrow, it automatically gets the rules. No extra work needed.
And this diagram breaks down the three main ways you'll see DCACI used. First is any-to-one, which is that classic shared service model we just talked about. Second is one-to-any, the reverse. Maybe you have a monitoring server that needs to reach out to everything. And third, well, there's any-to-any. This lets all EPGs in the VRF talk freely to each other. Now, you got to be careful with that one, right? It kind of defeats the purpose of zero trust if you're not careful, but it definitely has its uses.
So there you have it. We've gone from the core deny by default principle, all the way through the provider-consumer model, deconstructed subjects and filters, and even seen how DCACI can make it all scale. You now have all the building blocks you need to create some seriously secure and efficient network policies with Cisco ACI. So the only question left is, what are you going to build first?